Today, this is a different video. I do have two springs here, and I'm trying to compare which one has greater spring constant. So in this activity, following equipments are needed or following tools are needed. First, of course, you need to have those two springs that you want to compare. In our case, both of them are extension spring. So I will be comparing two extension spring to see which one has a greater spring constant. Next, that I will need are sets of mass. Sets of mass. A little bit um, paints or a little bit ding, and so that's why I use tape to measure and determine which one is which. So I have my 100 grams. I have my 200 grams right here. Well, let me just use the other camera, so it might be easier for you to see. So right here I have my 200 grams. So I have 200 grams. I have 1,000 grams or 1 kilogram mass. And then I have 500. And then of course I have already shown you the 100 gram mass. In addition to the springs, which I have right here, I will also need a metric ruler where I have my measurement in metric, either centimeters or millimeters, and then I will be able to convert it into meters. Now another device that I need is a ring stand or a physics stand right here. So I have my physics stand, which will be used to hang the spring. Okay, so without further ado, let us proceed with the experiment. So step number one, what I want you to do is write down the procedure. As I'm saying it, I'm verbally saying it to everyone. What is the first step? Okay. First step is to place our spring. So let's select which spring we're going to test. So let's start with the first spring. What I'm going to do is attach the spring. Okay. So step number one, attach the spring to the stand, to the physics stand. So let's hang the spring. Okay, so hanging the spring, as shown right here. Next is to measure the length. Okay, so let's measure the length. What is the free length of the spring? Okay, so let's measure. So I'm going to zoom it in. Of course, I want you to see the actual spring. I'm hoping that you could see our measurement. So here is our measurement. Oops. So if I'm going to measure here, so after you hang the spring from our stand, the next step is to measure the free length. So let's measure the free length. So as I'm going to switch from one camera to another, first, step number one. Step number one, hang the spring from a stand. So that will be our first step. Let me zoom it in so you can see. Apologize for my handwriting. Second step is I'm going to switch from one camera to another. As I'm going to switch from one camera to another, and that is to measure the length of the free length of our spring. Again, let me switch cameras. Step number 2. Okay. The procedure is using a metric ruler measure the free length of the spring. Now let's get back to the demonstration. Next step is to hang one of the mass starting from the smallest mass set, and in our case that is 100 grams. Doesn't even affect. Okay, so it will not affect, so it means that it's very strong. Okay, so it's very strong. Now this will give us I know what you're gonna say. It is biased experiment, but we all know that it's very strong and it doesn't affect any at all about our spring. So even though that is the procedure, of course the procedure is to hang the first mass. So what I'm gonna do, I'm gonna start testing my second mass, which is 200 grams. So at least with 200 grams, there is a slight change. Right? So there is a slight change, and just to let you know what my recordings are, free length is equivalent to, I'm just talking about the helix of the spring. That is around 28 millimeter. Okay, so 28 millimeter. Now let me just go back to so I'm going to start by L naught, which is our length, the free length. So I'm measuring this, which is 27 millimeters. So 27 millimeters, it means that at L naught, there's no mass connected. Next, let's call this one length number 1, L sub 1. I will place my 200 grams. I'll be switching cameras. You know what? Let me see if I can actually change this a little bit on size. Oops. Use this instead. I'm just going to fix the camera. As I hope this setting will work. Now, 200 grams is attached. Now let's measure our length. So L number 1, that is your length, and it moved at 330 millimeters. Write it here. So I'm going to write it here, 30 millimeters. Okay, so before I continue, what I'm going to do is write the third step. Third step is to hang the mass at the free end of the spring. At the free end of the spring. Measure the change in the length using a ruler, a metric ruler to be exact. Measure the length of the spring. Of the spring. You can see it. So now, what we're going to do is to repeat the process, and that is to add mass, to add at least an interval of 100 grams, okay, from 200. Okay, so let's start with 200, and then let's add another mass of 300, and then from 300, change it to 400, and then from 400, put 500, from 500 to 600, so you just keep on adding, and then 700, please observe, okay, so what happens with the length of the spring. So that's 700, and I'll add another 100 out of 700, let's see what happens. Okay. So now it's increasing in terms of length. Okay, so it's increasing in terms of length. Now you can refer to video number, I think it's video number 3, where it explains about how to figure out or calculate for the spring constant of a extension spring. So that's 800. Now it's 900. And then 1,000. So if you want to keep on going, so if you notice the spring's length is smaller now compared to 1,000. So here you go. So you don't want to have harmonics. So when it was by itself, it is 27 millimeter. Now that I have 1,000 grams, let me just measure it out of curiosity. So hard to measure. Okay, so I'm not supposed to be measuring upside down, but that's the only way that I can measure it because I keep on hitting the mass, the bottom part. Right. Some of you might say, why don't you use a meter stick? Well, the issue with a meter stick, because it's longer, it will not be easy to measure the length. There's no space to put your meter stick. So this will give us a measurement of 87. Let me just double check. Is it 87 or 82? Can I even see the graduation? It is 84 millimeter. So 84 millimeter. So now what can I say over here for number 4? Okay, so usually it's about 4 steps and that's it. Okay, 4 steps, that's it. So all you have to do is repeat step number 3. Okay, so all we have to do is, again, repeat step number 3, except increase the attached mass is to increase the mass. Okay? To increase the mass at an interval. Okay? So that would be a procedure. Okay, so that's the actual procedure of the experiment. Now, I will be pausing the video and I will be collecting additional data, and then we will be discussing on how to analyze the actual data as your next step.